Picking up where we left off. In this video we are going to finally load the code onto the dev kit, which is Cypress CYUSB3KIT-003, which I have connected to computer with two cables. One is a USB 3 cable and another one is a mini USB 2, which is going to be used for UART login. With that said, let us what else do we need? We also will need something to look at the UART login, which will be using PuTTY monitor. But let's start with the drivers, because drivers are important. Cypress CYUSB3KIT 1.3 driver. This is being run on Windows 10 64-bit. So let's go ahead, right click, and this is a setup information file, the .inf, and install. Yes, I know what I'm doing. And also let's go to online and get ourselves download PuTTY, PuTTY, free SSH and Telnet client. I actually like it. It's simple, but it gets the job done. It does what I needed to do. It shows me stuff. Open file, let's install it real quick. Next. I think I'm happy with the default options. Yes, I do know what I'm doing. I don't want to read readme file. Okay, so this is that. I just heard a few blooms. Let me see, what do we have here in device manager. In device manager we have the COM port. This is our UART, and we will be running at, let me go back here and make sure. Let's see, where was that? I think I've seen it here. Right here. Right, so this is gonna be 115.2 kilobaud with stop bit, no parity, and no flow control. Okay, let's set up the COM port accordingly so we don't run out of speed. 115.2, 8 bits, no parity, 1 stop bit, no flow control. Good. And another thing I'm looking forward in here, you know what, let's set up a little more. So camera, we'll be using camera, we'll be looking finally at the video output. And also PuTTY, pin to start. And another thing I wanted in here was Cypress, right, control center. There we go. And let's start with the Cypress control center, which will show us the devices connected. I think it has some code already. Let me hit the reset button on the device, and there is our bootloader device. That's the one we'll be loading the code into. Now let us go to PuTTY and say we want a serial. It's gonna be COM4 with 115200, and let's set up the no flow control, data bit 8, stop bit 1, no parity, all good. Let us save this session as well, UART. Save. Let's open it up. Let's have it running somewhere on a side. Let's have a little more space for our things. So let's have this over here, UART running over here, control center in here. That will make this window a little bit narrower over here. And the next thing is to load the code. Let's just go with release build. Do we have it built already? I think we do. One thing is, let's clean up a little bit here, because first of all, we will not be building with Cypress anymore since we have our build system set up here, so we're not gonna be comparing. And on top of that, I want to reduce, you see this verbosity, there is a lot going on which I don't like. So these guys I don't like. The finished, there is no reason to say that. This is probably fine just like that, and the same goes for building these files as well. So let me remove this. Yeah, this, that's already simpler, and this target is being built, and the linker we don't need these lines. We don't want to know the details, at least for now, of all the options we are running. This make for the post build. You know what, this is not the way to do it. The post build is essentially a way to build the image file. So why don't we state it explicitly that this is the rule to build this file, which will require an elf file for the build, and if it fails, we want it to fail. And you know what, with that we can use automatic variables, which for the elf file is our first dependency, so that's left or less than sign, which you probably want to put into double quotes just in case there are spaces in the name. And the same goes for this image file, which is our target, so that is going to be the @ symbol, and once again put it into double quotes to avoid issues of past names. The same goes here. The image file is our target, so we can just say the target, and of course double quotes just for future reference. And the same for this guy, we just can, not this but this. No, this is not true, this is going from here. Yeah, this is from the build type, from the current directory, target name. And what else we have? Alright, so this is no longer needed, because in reality this is building the elf file, which also means that this all targets is the one that builds the image file. So you see how it works. The all requires the image file, and the image file which come here, and it requires the elf file to be built. It will produce the image file, and the elf is from here, and the rules are all cascading down. On top of that, I think this is good enough. Let's hit oh, you know what else I want to do? I want to be able to build from the makefile itself. So let's add that into our list of tasks. Hello, where we have a build, we will have another one which is very similar, build all, but this applies to makefile. So whenever I am in a makefile, I can hit Ctrl B and get my goal of building the current spec. This output is so much clearer now, I like it, so I see which files are being built without any extra noise. Finish building target, I don't want that. If it's done, it's done, if there are no errors. And these are kind of pointless comments. I don't like pointless comments because they get outdated and they don't provide any clarity anyway. What else is here? Erase. Okay, so these are all if we ever uncomment that, I don't want to, actually I do want to see that. With that, what's on our list? Right, UART login. So we have built, let's just build it again, have built the release mode. So we click on the bootloader device, and by the way, by default it was LED blinker something or the other. So once I hit the reset button on the board itself, then it moves into bootloader device. Sometimes I need to click it twice. Now let's load into RAM, and we will go to this PC, our S drive, embedded ++, which is coming from the build, from release. Let's load it up. Does that mean that we have something to look at? Where is our camera? And oh my god, we do have a video which is kind of schizophrenic, if you ask me. I don't like how it blinks, it's too fast. I understand 60 frames, but it's you know what, let's slow it down. That would be, I think, somewhere here. If we look for the, let's Control ML, just collapse everything and look at what we have. Is that going to be here in the thread entry? Oh, look at that for loop, that may be the one. Set frame, UVC header, while application is active, wait for the next free buffer. So let's add a little bit of a delay here. CYU3P thread sleep, I believe is the name. Let's just add like 250 milliseconds delay. Let's build. We don't have a what's it called, the device in the list over here because it's not in a bootloader mode. So let us hit on the device the button, reset button, and hope there it is. Bootloader device, program, RAM, this dude, boom. And let me get to camera, and what do we have now is a much calmer video. At least now I'm not afraid of showing it to people with epilepsy. Another thing, we can build from here, but it would be also nice to deploy, right? From just right here, build, rebuild, clean, and deploy would be a nice option, because then we don't need to go into control center. Let's see how we can achieve that. If we go to Cypress, I believe it was in util, right, there is a CYFWProg. Let me see what it does. Command, let me just drag and drop over here and see what it does. It's a utility to load a firmware image into our device, and it has a few options. Used for verbose logs during the programming process, used to print this help information. Okay, so just give the name and the programming location, which is system for the RAM, I2C EEPROM, and SPI flash. Now, last minor thing is to figure out if we have an access to it, and I believe that would be FX3 install path, which takes us all the way to 1.3, and then we just need to say util and cyfwprog. Let's go back here, go to makefile, and add a new target, which is called deploy, not surprisingly. Deploy. Obviously this will be a phony target because it doesn't produce a file as such, and this file, this rule does depend on the existence of the up-to-date image file, so it comes into here as our dependency, which will trickle all the way up if we change any of the other files. And what we need to do here, don't remember, it's a tab over here, not space, it's always a tab. What we need in this place is well, let's start with the echo, right? So echo deploying image to RAM. I think it's a good enough explanation. And what we're gonna have here is, let's start with was it FX3? Oops, I copied the wrong thing. Let me go here and hit enter to copy it, and now hopefully, yep, FX3 install path, and then we have, what was that, util cyfwprog, Cypress FX3KIT-003, and obviously this all can be in the passes with spaces, so let's add double quotes around that. And the parameters were -fw, if I'm not mistaken. Let me see. Yeah, -fw firmware image file and then destination. So -fw, the image file is gonna be our target to build, which is the first, not the target to build, the first dependency. And the destination is the system, which is for loading into RAM. I'm not gonna be having the add symbol here yet because I want to see how it looks like when I hit it. Obviously, we also need to add that into our list of tasks. The deployment, let's just have it over here. Control D to duplicate and deploy to RAM, which applies to root, which context type is actually, it's not a context type. I don't think there is a deploy. Is there? Let's just see, but I don't believe so. Yeah, there is custom, which is not what we want. So type is going to be launch, and also for the arguments we want to say deploy. That should do it. Let's see if we have it here. Run deploy to RAM. Good. Let's see what happens. We don't have this item over here because we did not reset the what's it called, the device yet. So it says error in detecting FX3 boot device. Reset the device and try again. That's a good message. It's an appropriate one. So let's hit the button. I hit it twice. Wait for it to appear over here. Bootloader device. And now if I deploy to RAM, it should hopefully work. And it did work. Let's verify with taking a look into video. It's right here. That means I can clean up over here, put the add sign, and now our output is so much cleaner. We have cleaned up everything here. Next thing is I think that's UART login. The thing we ran it for. Oh, there is our UART login. It's been here all along, which I did not notice. Let's see once again. If we start the video, we get something here. And just to be more explicit about what do we get here, let's go to where it was initialized. Control ML to undo all this, and let's go to where we had our debugging through UART set up. It's over here. So after everything is said and done, over here we can just say congratulations. So CYUSB3P debug print. There we go. Let's say we always printed hello world, because why not? UART will require both return carriage and new line, otherwise it's not gonna be as good. Let us reset the device so we get into the bootloader programming mode. Let's also clean up over here, clear scroll back, reset terminal, and now if we deploy, run deploy to RAM, we should be getting a hello world over here once it loads. There is our hello world. I'm not sure what this character is, but we'll figure it out next time. And to some final check over here, we have our video working. With that, I will of course check what we have here. We have added the hello world, we added some delay, we have cleaned up a little bit our makefile, and we added JSON. So this is our season 1 episode 7, which is test the code on CYUSB3KIT-003 hardware, because from now on we don't need to rely on byte-to-byte comparison with what Cypress builds. We'll be able to verify whether the code we are building actually works on the device itself. So we can move away from just a quick note. Currently, for the ARM, what was it, GCC? No, let me see, what was it called, makefile. We were running ARM non-EABI GCC, the one that comes with Cypress is ancient, to say the least, -v. And when I say ancient, it's 2013, and today on the calendar is 2025, so it's 12 years, well, give or take, it was November, 11 years old. It's version 4.8.1. In comparison, if we were to go to Visual Studio that we have installed here, where do we go? Well, Visual Studio, of course, but then we go down to Linux, I believe, GCC ARM. If we check this GCC version over here, -v, you will see that it is way newer. It's 7 years newer. Still not the latest, but still it's 2020 and it's version 9.3.1. I'm actually hoping Microsoft updates it to version 10 soon enough, because there are some great C++23 features in there, but even that is a huge step up. So now when we move on to the toolchain, to use Microsoft toolchain instead of the one provided with the Cypress, we obviously will not be generating the same byte binary as Cypress was. So for that purpose, we are no longer going to be doing this comparison. We are gonna rely on testing whether the video is running or not. And with that, I will see you in the next video. Thank you for watching.